All right, so the whole reason that we went back in time and did the algebra review is so we could do the geometry, and then I know that you've actually been taught this stuff, okay? Because like I said earlier, the whole reason I did that because I noticed fairly early on that you guys were really lacking in your algebra skills. So I handpicked these worksheets because I know that you're going to have to do this stuff later on in geometry. This is the last week we're doing the algebra review. Next week we're going back to geometry, and you will see problems where you're going to have to do what we're doing right now, okay? Some of you guys were already able to do it. Many were not, so that's why we did this. I'm just going to start with number 1. This is called a one-step equation. Tomorrow will be a two-step equation, and then the next day will be a multi-step equations. What we're doing this time is we're solving for x. We're getting x by itself, or whatever letter they give us. This worksheet company gives you all these different letters. I like using x, and I think I'm just going to use x instead of the letters they provide. All right? All right, so there we go. Now, let's briefly, we only got like less than 10 minutes left. All right, so I just want to say, let's do this. Put this one on hold for a second. What if I said 5 equals 5? Would you agree with that? Yeah, of course. Okay, now watch what happens. Now, I've got the left side. The left side of what? I'm going to talk about the left side, right side. What am I talking about? The left side of the what? Of the equal sign. Of the equal sign, okay? So I've got the left side of the equal sign. I got the right side of the equal sign. Now watch this. If I added a 2 to the left-hand side, are they still equal to each other right now? If I added a 2 to the left-hand side. No, because this would be a 7, this would be a 5. How could I keep them equal to each other? How could I keep both sides the same? Do the same exact thing to the other side. Exactly right. So if I add something to one side, I can also what? Add it to the other side. Everybody with me on that? All right. And then look, these will still be equal to each other. Now, they're not both 5, but they are still equal to each other. Agreed? I could do the same thing with multiplication. Let's start with a 5 equals 5 again. What if I multiply this side by 2 and I multiply this side by 2? Do they still stay equal to each other? Yeah, absolutely. Okay, so whatever I do to the left side, as long as I do it to the right side, they're still equal to each other. I still have an equation. And that's what it means to have an equation. It means that that you have an equal sign. That means the left side is going to equal the right side. Would this make sense? Whoops, that doesn't make sense. Let's try that. It's this button on my pen. I talk about it all the time. I accidentally push this button on my pen, and it acts weird. So what if I did this? Could I say that? Is that a true equation? Is that an equation? No, that's an inequality, right? They're not equal to each other, all right? So this would not be true. So when you have an equal sign, it means the left side is going to be the same as the right side. Everybody with me on that? Okay. Now, here's another thing. Let's do one that's even easier than that one. What if I said, what number plus 2 is going to give you 5? All right? So what number, if I add 2 to it, am I going to get a 5? It's going to be a 3, correct? Everybody see that? But what we're going to do, instead of putting a box, we're going to write what? An x. So I'm going to put x plus 2 equals 5. Now, you could probably just look at it just like you did with that empty box. Look at it and say, what number plus 2 is 5? You could probably do that in your head. Everybody could do that in your head. So what number, if I add 2 to it, am I going to get a 5? 3. But let's try to solve for x in a more calculated way, okay, a regimented way. So what prevents that x being by itself on the left-hand side? What prevents it from being by itself? What's with it? Because is the x by itself on the left-hand side? No, it's got something with it. What's with it? The 2, right. And what is that 2 doing to the x? It's adding, isn't it? All right, so I want to get rid of that 2. I want to get x by itself. I don't want anything with the x. I just want x by itself on the left-hand side. So I have to get rid of something. I have to get rid of that 2. So you look at it and you say, well, what is that 2 doing to the x? Is it multiplying? Is it dividing? Is it adding? Is it subtracting? What is that 2 doing to that x? It's being added, isn't it? It's x plus 2. So how could I get rid of something that's being added. You probably learned this in your algebra class. What do? You do the opposite. What's the opposite of addition? It's subtraction, correct? Okay, so what I'm going to do is this. I'm going to subtract a 2. Now remember up here, whatever I do to the left side, talk to me. I have to what? Also do the other side, okay? So whatever I do to the left, I got to do to the right. So if I subtract a 2 from this side, what am I going to have to do to this side? Subtract it from the 5, but subtract a 2, correct? Why do I do that? Because I got to keep them balanced. I got to keep the left side equal to the right side, all right? And that'll keep the left side and the right side equal. Now what happens here? Why did I subtract a 2? Because 2 minus 2 is what? It's 0. Well, it's 0 plus x. But what's 2 minus 2? It's just 0, isn't it? What's x plus 0? X plus 0 is x. So I'm just left with an x. Now, a lot of times, Josh said it already, but a lot of times we say what? They cancel out. And that's fine. I don't mind you saying they cancel out. But I need you to know why they cancel each other out. They cancel each other out because they add up to 0. All right? That's why it goes away. X plus 0 is just x. We don't have to write x plus 0, though, do we? We just get rid of the 0. And then x equals what? 3, just like we said it does. Let's do one more. What if I had 3x equals 12? Now, I want to get x by itself. What is that 3 doing to that x? It's multiplying this time, right? There's no sign in between. It's being multiplied. So we got to get rid of the 3. So what's the opposite of multiplication? It's division. So what we're going to do is we are going to divide by a 3. Come over here, divide that by a 3. Why did we do it to both sides? Because whatever we do to the left, we do to the right. Now look what happens here. What's this 3 over 3? What happens to that? We could say cancel, but what do? Do they add up to 0 like these two did? No, they don't. What happens? What's 3 divided by 3? What's anything divided by itself? It's 1, isn't it? So the 3 over the 3 becomes a what? 1, and then that 1 is doing what to the x? It's being multiplied. That's right. And what's 1 times x? It's just x. So that got rid of the 3, didn't it? Okay, but it got rid of it for a different reason, though. Right here, they added up to what? 0. X plus 0 is x. Right here, what'd they do? They divided, didn't they? So 3 divided by 3 is what? It's 1. 1 times x is x. Or you could say they cancel out. Okay, sometimes we get so used to saying they cancel out and not know why they cancel out. They cancel out for 2 completely different reasons here, don't they? These add up to 0. These divide out to be a what? A 1. 1 times x is x. Does that make any sense? Yes? No? I'm getting some people nodding, some people dozing off. All right. Now we figure out what this is. What is this? 12 divided by 3. What's 12 divided by 3? It's 4, and there you go. That's your answer. This is how you would show your steps. Let's go to this. I got to finish up. I got 2 minutes. I got to get x by itself. What is on the same side with the x? And x could be on the right-hand side. It doesn't always have to be on the left-hand side, okay? So the 8. What is the 8 doing to that x? It's adding. So how do I get rid of something that's being added? I subtract it. So I subtract an 8 from this side, and I do what? Subtract an 8 from the other side. These cancel out. But why do they cancel out? Because they add up to 0. It is a 26. All right, so x equals, and then whatever 26 minus 8 is. What's that? 18? Yep. All right. And there you go. Now you could put 18 equals x. If you don't like that, and you always like x on the left-hand side, it's fine just to do that. I kind of like the x on the left like that anyway. What do you think? Let's do another one. I'll give you the paper before you leave. Okay, I got 1 minute. Let's do one with multiplication. Let's do, well, some of these numbers, you may need a calculator. Here's one that you don't. 10x equals 40. Okay? So, how do you get x by itself? Divide it by 10. Divide this side by 10. That cancels out. X equals what? What's 40 over 10? 4. And that's it. Let's do one more. The bell's going to ring in a second, but let me do this one. I'm going to do this. let's go negative 6 equals x over 3. Now, this is a little different. Now, everybody look up here and watch. Everybody pay attention. Everybody's up here. Don't pack up. Everybody's looking up here. I got to get x by itself. What is that 3 doing to that x right there? It's being divided, isn't it? Okay, it's x divided by 3. How do we get rid of something? We always do the opposite. What's the opposite of division? It's multiplication. Don't leave yet. So you multiply this by 3, and then you do what? Multiply that by 3. Look, those cancel out. X equals, what's 3 times negative 6? Negative 18. So you're right, x equals negative 18. And there you go.